Hello, I'm Tim, Applications Manager at Zurich Instruments. Are you in the market for a new impedance analyzer? This video will help you make a smart choice. An excellent starting point when shopping for an impedance analyzer is the reactance chart provided by the manufacturer. This chart shows you the accuracy that you can expect for a given frequency and impedance value. Let's first look at the frequency range, as this will define how much you're going to pay. In this example, the logarithmic x-axis goes from 1 MHz to 5 MHz. But higher frequency analyzers are also available. And it's not just the upper frequency limit which increases the cost. Instruments which can measure impedance at low frequencies command a premium too. Choose a frequency range that matches the use case of your devices or the typical phenomena which need to be characterized. If you're not sure about your future needs, consider an impedance analyzer which can be reconfigured at a later date to add the frequency range you may need. The next thing to consider is the impedance range. Do you need to measure high impedance at the teraohm level or low impedances at the milliohm level, or both? Keep in mind, the absolute impedance of both capacitors and inductors change over many orders of magnitude as a function of frequency. The wider the impedance range of your impedance analyzer, the more fully you can characterize your components. Now let's take a look at the accuracy on the reactance chart. This tells you how close the measured values will be to the real value. For instance, if you want to measure a 100 picofarad capacitance from 100 Hz to 5 MHz, you can expect the following accuracy. To realize this accuracy in actual measurements, proper compensation of your measurement fixture is essential, so check to see that the instrument includes a flexible compensation routine that's easy to use and to understand. In addition to measuring impedance as a function of frequency, you may want to measure it as a function of other parameters such as DC bias voltage, test signal level, time, or even an auxiliary control parameter which would give you flexibility for future applications. Make sure that the impedance analyzer that you're considering can sweep the voltage to the levels you require to fully characterize your device. For example, when doing CV profiling. For drive level measurements, it's important that the test signal amplitude can be swept, and for advanced applications, combined together with DC bias voltage. Whichever parameter you choose, make sure that the impedance analyzer is both fast enough to resolve the changes and can also acquire enough data to capture the full transient behavior. For transients, fast but accurate measurements are crucial. As your device changes impedance, how quickly can the instrument measure that change? This example shows the Zurich Instruments MFIA measuring a steady-state capacitance of 2.3 nanofarad before a DC bias voltage is stepped. After just 20 microseconds, the MFIA can measure the new steady state of 1.6 nanofarad. The user interface software is critical to optimizing your workflow and can save you a lot of time and money. Choose an impedance analyzer with an intuitive user interface that allows you to take data quickly in the format you need. Consider the display tools. Do you want to display Bode plots, Nyquist plots, CV plots, transients, or time domain evolution? How about automation? Controlling your impedance analyzer via scripts saves a lot of time and integrates it into your whole lab setup. Whatever your favorite programming language, find an instrument which supports it out of the box. Impedance analyzers can also include ancillary tools to help with your measurements, such as an oscilloscope, spectrum analyzer, or pulse generator. Using these tools in parallel on the input signal will help you gain a more thorough understanding of what's going on in your sample. The user interface should be easy to use and grow with time as new features are added, ensuring a long instrument lifetime. There you have it. These 6 aspects will help you choose an impedance analyzer that best matches all of your requirements and costs you least in time and effort. If you need any advice, get in touch, we can help. Thanks for watching.